I don't have dyslexia.
Today's quiz involves 4 ramps. They're of different curves, but they all start and end at the same place. We simply want to know, if I were to take one of these metal spheres, one of these ball bearings, and let it roll down to the bottom, when it gets to the bottom, which one would have the greatest velocity? Here's what your quiz looks like. I'll hold that up for you now.
Velocity at the bottom of the ramp. Okay. I mean, the obvious. This one doesn't have enough time, it looks like, to build up speed. I would say that it's, if I had to guess, I would say these two are pretty similar. But if I had to guess, it's not about who comes down first, it's about who has the highest velocity once he's there. So I'm gonna go ahead and say this one here is the best.
As always, mark your answer as completely as possible and be sure to list your confidence. Student responses vary wildly. Some will say the red is absolutely going to be going the fastest because it's going
I mean, if you drop them at the same time, it's going to be a different answer than the actual speed at this point. At this point here. Not like who arrives here
at the
first.
steepest slope, especially at the end where it really matters. Others will say this yellow has a slow and steady, and it's going to have the greatest acceleration, and therefore it's going to be going the fastest at the bottom. Others
Maybe
will
it
say,
is
no,
all
no,
the same.
Blue gets going fast and stays fast for a very long time. It's going to be the fastest. Others will say green. While they all are going to be varied in their ideas, they're all going to be incredibly confident in their own ideas, which is so...
I'm not confident. I'm saying that if my second answer is all the same, just so you know, all the same.
Because they're all confident, but yet none of them agree. All right, let's see if we can explain this. Part of being a physicist or a scientist is not to be bamboozled. And that's really what we're doing here. Because if you think about the conservation of energy, and they're all starting with the same exact amount of energy, we would expect them to have the same amount of energy, maybe in a different form, down at the bottom. So they should all be going the same speed. Let me see if I can set this up, and we'll show you. I'm zoomed out so you can see the photo gate. Now I have a single photo gate, which is going to try to measure a round object. We have a long form lesson that talks about the difficulty of that. Let's not worry about that right now, and let's just assume as long as the ball is going through the gate the same every time, it should give us a relative measure of the velocities. Our problem is, as each one of these spheres comes off the ramp, they tend to bounce, and they can bounce over the beam. So we have a little piece of paper and some cardboard underneath here to smooth out that transition. What I'll do, I'll hit collect, I'll roll 5 down the red, and then I'll move the photo gate over, and then I'll put 5 spheres down the green and let it go through the photo gate, and so on. And we will see how the velocities correspond. I'll hit collect, and we'll get started.
Why 5 though? 2 is enough, is it not?
1, 2, 3, 4, 5. I'll move the photo gate over. I'll get 5 more, and we'll try the green. 1, 2, 3, 4, 5. And you can see right away that they appear to be about the same. Let's try our yellow. 5 unit spheres. 1, 2, 3, 4, 5. Again, looking very similar. And I'll move this over here. And let's try our blue. I'm trying to release them at the same point on the ramp, despite their color difference. And that's fine. And I think we can clearly see that all of the velocities are about the same, as they should be. Because if you use the conservation of energy, we know that potential is going to be converted into kinetic. And if they all start with the same potential energy, they should end up with the same kinetic energy, and therefore should have the same overall velocity. That's why the conservation of energy is such a wonderful tool. It's so simple. All right, that's your quiz for today.
Looks like yellow was the fastest. Just saying this. That's what it looks like to me.